So hello everyone. So welcome to LeetCode 29 day challenge, and in today's challenge we have the question longest rectangle in histogram. So in this we are given different bars like histograms, and we have to find that what can be the maximum area of the rectangle which can be made using this histogram. So this question is based on stack, and this is particularly based on the concept of next greatest integer. So this question can be solved in three different ways. So I'll be solving this question all these three different ways, from the brute force solution to the most optimized solution. So I'll be explaining my solution with the help of a blackboard. So now moving to the solution part. So this was the example which was given in the question on the LeetCode, and here we have these 6 histograms, and we have to find the maximum area of the rectangle which can be found by this histogram. So for finding the area, the trick is that for each histogram we need to find the next smallest element in the right side and the next smallest element in the left side. So let's do it by using a brute force solution. So for 0th index, I can write that the area will be 2 multiply the area which is the histogram which is the smallest in the right side. So it is here. So I can just like write, say, 0 minus 0, because if I am using 2, so my area will be from here to here. Okay, this will be this much. So this will be from 0 to 0, and we will be adding plus 1. So this will be 2. Now for the first histogram, like this is the 0th histogram, so this is the first histogram. For first histogram, the value will be 1 multiplied the smallest in the right side, that is at 5th place, like it is at the 6th index, but we have to go till here, like till this part. So this will be 5 minus 0, because we have to go till here. This is minus 0 plus 1, so that will be 6. Now for the second histogram, it will be 5 multiplied what is just the smallest in the right side, so it is 2. So this will be till here, that is 3. 3 minus the smallest in the right side, so 1 is smallest in the right side, so we'll be making till here. This is my 2 and plus 1. This is actually the formula, right minus left plus 1 for the third histogram. So this will be 10. So this will be equals to 10. So this will be equals to 10. And for the third histogram, it will be 6 multiplied the smallest in the right side, so this is 2. So again we'll be going only till here, so this is 3. And in the right side also there is like no small, like this is the smallest, like 5 is the smallest, so we'll be going till here. So this is 3 minus 3 plus 1, so that is 6. So now like this we will be calculating for all the values, and my 10th will be the largest value. So like this we can find the value of, so by doing this we can find the answer which is required, which will be 10. But when talk about time complexity, the time complexity will be big O of n square, because for every histogram we are finding in the right side also and in the left side also. So if we find for every histogram in the right and left, so in the worst case there can be a possibility that we have to go till here n. So that's why the overall time complexity will be of n square. So this will obviously give me a time limit exceed if I try to code it in LeetCode. So now let's talk about the more optimized solution for this. So now moving to the more optimized part. So we'll be using an NSE stack to solve this problem. So NSE is like next smallest integer. In this we store the value which is like next smallest to a particular value. So we'll be making two NSE stacks, and in the first NSE stack we will be storing all the values from left to right. and the second NEC stack will be storing all the values from right to left. So now let's start from left to right. So for 2, so what is the next smallest integer from 2? So that is 1. So we can just like write here for like if we are starting from 2, so we can make our rectangle till here, because if we go after 2, so this will be less, so it will be 0. For 1 we can go till here 5, right? So we'll be writing at 5. And now for fifth, we have the next smallest integer, which is here 2. So we'll be taking this because it will go till here, so that will be 3. Now for 6, we'll be taking the next smallest, that is again here, so we'll be taking the same 3. Then for 4, we'll be taking the next smallest, which is here 5. And for 3, we'll be taking the next smallest, which is 0. So again this will be till 5. So now moving from right to left, we can see that like 3. So what is the smallest value for 3? So that is at 4th index. So we will take the upper boundary of it. So that will be 5. So again we will see what is the smallest for 2. So that is 1. So we'll be again taking the upper bound of it. So that will be 2. So now we'll be see what is the smallest for 6 in the right side. So that is 5. So again we'll be taking the upper bound. So that will be 3. Now for 5 we will be seeing which is the smallest. So that will be 1. So we'll be again taking the upper bound. So that will be again 2. So now for 1 we will do the same. So that will be -1. So for again the upper bound. So that will be 0. And now for 2 again -1. So we will be taking the upper bound. So it will be 0. So this is the value from right to left, and this is the value from this is the value from left to right, and this is the value from right to left. So now once we have the value for these two stacks, we can just take the value of the histogram like 2 and multiply and subtract this minus this. So that will be 0 minus 0 plus 1. So that will be 2. Now for this first histogram, like the first index histogram, this will be 1 multiplied 5 minus 0 plus 1, means this is whole bracket. So this will be 6. Now for the third histogram, for the second histogram, second index histogram, we have 5 multiplied 3 minus 2 plus 1. This will be 2. This will be 10. Now for the third histogram, we will be having 6 multiplied 3 minus 3, that is 0 plus 1, that will be 6. Now we will be doing the calculation for all the histograms, and eventually we will find that 10 is the highest, which we got for the second histogram. So 10th is the highest. So this will be our answer. So the overall time complexity in this case will be O of n. Actually we are doing 2 passes, so this will be 1 pass n and then another pass n. So this will be O of 2n, and the space complexity will be 2 stacks. So this will be O of 2 into n, the space complexity. The time complexity and the space complexity both will be this and this. Now is there a better solution for this? Yes, there is a better solution for this, in which we can just find the value in just a single pass. So now I'll be explaining that single pass solution, and I'll be coding that. So now here is the time to go get to the most optimized solution. So in the most optimized solution, we will doing only one pass from left to right, and we will maintain only one stack, and using only this we will be able to calculate our answer. So there will be 3 operations which I will be doing in my stack. So the first operation, if my stack is empty, I will be just inserting I to the stack. Suppose suppose my stack is not empty, and if my top's value is greater than my h, means the current value I. If this is the condition, then I will pop it out. If I will pop it out, then I will do some operations. And if this condition is false, means the stack is not empty, but the st of top is less than I. So I will be just inserting I. So these 3 operations will be done. So let's start. So 2. Right now my stack is empty. This is my stack. So my stack is empty. So I'll be just inserting 0. So now my I moves to the first index. Now we'll be checking whether my stack is empty. So this first condition is false. Now second condition, whether my stack of top, that is 0, is value greater than my i's value. So yes, my 0 value, that is 2, is greater than 1's value. So I'll be doing some operation. So what will be the operation? So first I will be popping my stack, and I will be storing my value that is popped in a variable, let's say named val, and this will be storing the value of st.top. And then I will pop this value, like my stack will become empty, and I will be storing two more variables. One is left and one is right. So if my stack gets empty, my left will get -1, or if my stack doesn't is not empty, so my left will get stack of top after popping the value, and my right will be the current index, that's I. So the formula is that for every second condition, we can do that. It is 2 multiplied I minus left minus 1. So this is our value. So in this case, my val is 2. So in this case, I can see that you can see that my val is 2. So the formula, it is 2 multiplied 1 minus -1. So that this makes it +1 -1. So this is 2. Now taking my I2 here, that is the second index. So we'll be again checking. So my stack is empty. So first condition is true. So I'll be just inserting my I. So that is 2. And now I'll be taking my I to the third index. Now I'll be checking which all conditions are true. So this is false, this is also false, this condition is true. So I'll be just inserting my 3. Now I'll be taking my I to here. One thing I just forgot to mention, that once you do the second operation and after doing the operation, we have to push the ith value. So I just forgot to push 1 here. So you have to keep this in mind, that you have to push the ith value after every second operation also. So now my I gets to 4. So is the value, so the second condition satisfies, that is the top value, that is 3's value, that is 6, is greater than the current value. So now we'll be doing this calculation. So first we'll be popping this out. So my val becomes 6 and my I is 2. Sorry, my left becomes 2, that is the stack's top, and my right becomes the current I, that is 4. This will be 6 multiplied 4 minus 2 minus 1. This will be 6 multiplied 1, that is 6. Now I'll be again doing the same operation unless and until this condition gets false. So this condition will be in the while loop. So I'll be popping the 2 out. So my value gets equals to 5, and applying the formula means the left becomes 1 and my right is still 4. So applying the formula, it is 5 multiplied 4 minus 1 minus 1. So this is equals to 10. And till now 10 is the maximum value. Earlier we had 6, but now 10 is the maximum value. So we'll be storing it in a variable named answer, that is 10. And then I will popping out 1 also. Let me erase it once. So my array was only having, so my stack was only having I, that is 1. So my stack was only having 1. So now let's try to pop it out. So the value of 1 is 1, and my left will become -1 because right now there is no more elements left, and my right will be still 4. So again the formula, so it is 1 multiplied 3 minus 1, so that is 2, which is not greater than 10. So I'll be taking my I over here, and I will be just keep on doing these things again and again till I'm finished with all the indexes, and the maximum value which has been calculated will be printed. So this is the best and the most optimized solution for this particular problem, in which the time complexity will be O of n and the space complexity will be also O of n. So now I will be showing the solution of this particular problem. So now moving on to the coding part. So this is the code, and here you can see I have used a stack, and as I've explained earlier, I have just iterated over the entire vector, and this is the condition, like if this stack is empty, I'm just pushing it in the stack, or if the stack is empty and is not empty and the top value is greater than the current value, so I'm doing all these things which I've already explained in my explanation. And suppose if my top value is less than h of I, so I will just insert it, and the maximum value is getting stored in my answer, which will be printed. So this is the entire code. So let me just run it once. So as you can see, it got submitted and accepted with 89%. So thank you for watching my video, and if you have watched this far, please consider subscribing. Thank you.